All right, hey guys, welcome back. So we got a redox reaction and we're going to balance it in a basic solution. This was probably like the most requested video that you guys wanted. So here we are. This one has a little bit of surprises in here. So to help us out, we're gonna have our redox rules with us. So this is posted on Gausha Space. You guys got an open note test, so you can use it. Anyways, the first thing is we're going to write the oxidation and reduction half reactions. And in order to do that, we need to assign oxidation states to everything. So let's go ahead and do that. Chlorine is in its elemental form. So its oxidation state is going to be 0, right, Cl2. Remember the diatomic elements, so everything that exists in elemental form has 2 diatomic elements are these guys, which I've talked about before, where it's like never had fear of ice cold beer. So if you ever see these like N2, H2, O2, know that their oxidation state is 0 because that's them in their elemental form. Here we have an ion, so its redox state is the same as its charge, -1. Here we have a compound, oxygen is almost always -2. We have to balance it out with the -1 charge. That means chlorine here is +1. Right, so remember our key oil rig. I'll just write our notes down here. Oil rig, oxidation involves loss of electrons, reduction involves gain of electrons. Right, so this was a little weird because we only have one reactant, but that's okay. So we have chlorine. Let's make this our reduction reaction. Right, so reduction involves gain of electrons. So that would be like chlorine diatomic going to something that gains electrons. So this guy right here. So this counts as our reduction reaction. Let's go ahead and do our oxidation reaction. That would be losing electrons. So that would be like going from the neutral chlorine gas to something where it changed its charge, right? So that would be like +1, right? Losing electrons to be a +1 redox. Right, so this might seem a little bit weird because one reactant is showing up in both halves of the half reactions. That's okay because when we go through all of these steps and balance it out, it will work out. So you just gotta accept that's a little weird at the beginning and follow the rules and go with it. So we already did step 1, right? We wrote down the half reactions. Now let's do step 2. So balance all the elements besides oxygen and hydrogen. Right, let's do this for our reduction reaction first, right? The only really thing that we need to balance is chlorine. We need to put a 2 here to make sure there's 2 on both sides. Check. There's no oxygen and hydrogen in this half, so I'm just going to put check marks. We did it. And then we want to balance the charge. So the way I think about it is this entire side has a charge of -2. Right now, this entire side has a charge of 0. So we want to balance that out by making them equal. So we're going to add 2 electrons to this side of our reduction reaction. Balance that shit out. Cool. And so now they both have -2. So we're chilling. Okay, let's go ahead and do that for our oxidation half reaction. So we finished 1/2. Right now we need to put a 2 in front of this guy to balance all elements besides oxygen and hydrogen. And we want to just do part B. So balance oxygen using water, which means we have to add water to this side, and we're going to be adding 2. So now that we added water, what do we kind of mess up? Or we kind of mess up the whole hydrogen thing, but that's okay. We're going to fix it. H+. All right, cool. And now we want to balance the charge using our electrons, right? So right now this side has a charge of 0. In this side, we have 4 positives from H+, 2 minuses from this ion here. So +2, we want to balance it out, and we can only add electrons, so we have to add 2 electrons here. Right. Okay, check. So this is a great place to stop and check before you get in too deep and seeing if you're doing this right. So remember, oxidation involves loss of electrons. So as you go through the reaction, electrons should be a product because you're losing them. So check, we passed this test. Along the same lines, reduction involves gain. So electrons should be a reactant here. So we also passed this test, right? So you should be able to stop, make sure that, okay, if electrons are on the reactant side of one of my half reactions, they should be on the product side of my other half reactions. So we're chilling. All right, cool. So we would equalize the number of electrons on both sides by multiplying one or both reactions, but you can see here that we have 2 electrons on both sides, so we are chilling on this. Check. Cool. Now we're going to add the half reactions by canceling anything that's present on both sides. So this is where the stuff gets a little bit longer. So go ahead, maybe pause now and try to do this step on your own, or you can just follow along. Right, these are the reactants from the reduction and the oxidation. Now let's see the products. Did some work in there. All right, cool. So what can we cross out on both sides? Definitely the electrons, right? That's the whole point of making sure that the electrons are balanced. Is there any other way that we can simplify this? Right, one thing that we're noticing is we have 2 Cl2s. Let's just go ahead and combine them into one. It won't really affect anything that we're doing. Put 2 here. Cool. All right, great. Okay, so we did this part, right? And if we were balancing in acidic conditions, we would be completely done. Since we're balancing it in basic conditions, there's a couple extra steps. Pay attention to the number of H pluses you have. So we have 4 H pluses. We want to add that amount of hydroxides to both sides. So I'm going to do this step in a different color, maybe black. Plus 4 hydroxides, plus 4 hydroxides. Cool. So that's one step that we just did. Then we realize that whatever side you have hydrogen and hydroxide on, they're going to react to form water. So that would be these guys right here. So instead of writing them as individual atoms, I'm going to show what actually happens and write them as waters. So we would have 4 waters. Now that we've done that step, we can cancel out water that appears on both sides. Right, so we have 2 waters here, so I'm going to subtract that from this. Let me just write everything out again. So we still have the 4 hydroxides on the side. They didn't get removed. Plus our 2 chlorines. Plus our 2 chlorine ions. Plus now only 2 waters. Cool, so this would be our equation balanced in basic conditions. So remember at the beginning how it was kind of weird how we had 1 chlorine on each side? That was a little bit weird, but that's okay because when you look at this reaction now, all of our chlorines are balanced. So yeah, with redox reactions, just follow the rules and you'll be chilling.